then you integrate. Just follow these steps and you will do great. First you separate and then you integrate. Just follow these steps and you will do great. First you separate and then you integrate. Just follow these steps and you will do great.
Tis the season to be serving.
When I was solving equations, I was feeling amazing.
Okay, greetings pre-calculus students. Welcome to lesson 15. It's time. Okay, lesson 15 is on the average rate of change. Pretty straightforward, vanilla topic, but pretty important. And that's really all we're going to do today. We're not going to review anything. We're just going to get straight into the average rate of change. And to do so, I want to introduce a scenario. So I want to look at the following scenario. And it reads, a family is making a long road trip. They leave their house at 1 p.m. At 3 p.m., they have traveled 135 miles. They traveled 345 miles at 6 p.m. What was the average speed the family was traveling from 3 p.m. to 6 p.m.? So what was their average speed? Again, they leave at 1. By 3, they've traveled 135 miles. By 6, they've traveled 345 miles. What was their average speed between 3 p.m. and 6 p.m.? I really would like you to think about what you believe the answer is. So if you need some time, take a moment, pause the video, and see if you can figure out what the answer is. Okay, so let's look at it. So I'm trying to find a speed, and I know some distances, and I know time. And luckily, we were taught in science that speed is distance over time. So from 3 to 6, to get the distance traveled, we would just have to subtract 345 minus 135. And of course, to get the time that has elapsed, we're just going to do 6 minus 3. So we have that, which gives us 210 over 3. And so an average speed of 70. Of course, this is 70 miles per hour because the distance was in miles and the time was in hours. So the average speed was 70 miles per hour. And this is a type of rate of change. Anytime you take the average of something over a period of time, that's considered an average rate of change. If I look at a graphical representation of what we just did. So on this graph, I have 2 points that I've plotted. One is the point 2, 135. And you may say, why is the x-coordinate 2? Well, the x-coordinate represents the time since 1 o'clock. Remember, the family left their house at 1 o'clock. So at 3, that was 2 hours past 1 o'clock. So that's when t equals 2. And of course, that value was 135. And at 6 o'clock, that's when t equals 5, because again, they left at 1 o'clock. So 5 hours past, they give you the 6 o'clock. And then that gives you 345. Now we just figured out that the average speed was 70. And to get the average speed, we took the difference of the miles divided by the difference of the time. And on this graph, the x-axis is the time and the y-axis is the miles. And so what we basically did when we did that division is taking the difference of the miles is the difference of these two y values, which some people call rise. And when we took the difference of the times, that's the difference of these two x values, which some people call run. So when we found the average rate of change, we actually were finding the slope of this line. So the average rate of change is the same thing as slope from a graphical perspective. So that's very important to remember. Rate of change is slope. That's very important to remember in pre-calculus. That's very important to remember in calculus. Rate of change is the same thing as slope from a graphical perspective. So when you were in algebra, you learned a formula for finding the slope between two lines. So if I have a line passing passing through 2 points where the first point is x1 comma y1 and the second point is x2 comma y2, you are taught a formula where the slope m is y2 minus y1 over x2 minus x1, which is essentially what we did to find the average speed in this particular problem. For instance, our y2 was 345, our y1 was 135, our x2 was 6, our x1 was 3. Or in terms of time since 1, you can say our x2 was 5 and our x1 was 2. Either way, it gives you the same difference. And so this slope formula that you're very familiar with is actually the same formula we use for the average rate of change. Because again, a rate of change is a slope. So it's the exact same formula. We just do the formula using function notation. So this is the actual formula we use for the average rate of change. F of B minus F of A over B minus A. Again, F is synonymous with Y, so F and B and F of A are your two Y values, and B and A are your two X values. So in essence, you're still just doing the basic slope formula. So let's just look at a few examples of this process. Okay, so we're just going to look at 3 examples, and everyone should be an expert on this particular topic. Again, it's a very easily digestible, vanilla, straight to the point concept. So it says find the average rate of change of f of x, and it gives f of x as 5x squared plus 8x plus 7 on the interval 8 to 10. So let's look at that. Now, again, 8 and 10 are the interval of the x values. So my first x value, and again, average rate of change, to find an average of something, is done over an interval. So there's going to be an interval of time or interval of x values here. In calculus, we find something called an instantaneous rate of change, which is at an instant. But in pre-calculus, we find the average rate of change, which is over a period of time or some duration of some figure. So when they give you this interval, the first number is A and the second number is B. So in that formula, f of B minus f of A over B minus A, this is A and this is B. Now, f of B and f of A, those are things that I need to find. So f of B for this problem, since B is 10, is f of 10, and which is 5 times 10 squared plus 8 times 10 plus 7. So let's see, this is 587. So this is 587. So f of 10 is 587. Now f of A, of course, A here is 8. That's f of 8, which is 5 times 8 squared plus 8 times 8 plus 7. This calculation may not be as simple. And so this is 64 times 5, that's 320. 320 plus 64, that's 384, plus 7 is 391. 391. So f of 8 is 391. So again, when doing this problem, you're gonna have to find the values of f of B and f of A. So now I'm ready to do the formula. So just to remind you of the formula, again, for average rate of change, the formula is f of B minus f of A over B minus A. And so for this problem, f of B is 587 minus f of A is 391, and B is 10 and A is 8, so over 10 minus 8. And from there, we'll just do our little arithmetic. Looks like this is 186. That looks to be 186, correct? No, 196. That's 196 over 2. 196 over 2. So I believe that should equal 98. And that's it. That's all we have to do to find the average rate of change. So I will do 2 more examples just to make sure it's all the way in there, but it's a very simple formula. In fact, all I'm doing is the slope formula. But the deal is I do have to find these y values, if you will, for every particular problem. So let's look at the next problem. Okay, so that one was 98. And let's go and look at number 2. Okay, so number 2, we're finding average rate of change. F of x is 5x squared plus 2x plus 5 on the interval from 3 to 7. Let's have at it. Okay, so I think you kind of know the drill. So first thing I'm going to do is I'm going to find f of 7, which is 5 times 7 squared plus 2 times 7 plus 5. So this is 49. 49 times 5, that's 245. And this is 14 and 5, that's 19. And so that's 264. All right, so f of 7 is 264. Now I need to find f of 3. F of 3, that's 5 times 3 squared plus 2 times 3 plus 5. This is 9 times 5, 45 plus 6 plus 5. That's 56, I believe. And I will say, if anyone's having issues on the arithmetic, so these are fairly simple. All the problems we're going to do are going to be like these little quadratics for now, at least. And I guess the only thing to say is just remember to square before you multiplied. Had I multiplied first, I'd have 35 squared. 35 squared is 1225. It's a lot different from the number 245. So you want to multiply, then square. All right, so once I find my 2 y values, so this is the value of f of 3 here, it's to the races. So my answer is going to be f of 7 minus f of 3 over 7 minus 3. And so that's 264 minus 56 over 7 minus 3. So that's going to be 208 at the top and 4 at the bottom. And that would be 52 when you do the division. All right, so that's how that guy goes. Let's look at our last example. All right, so what do we got? 52. All right, last example. So go ahead and pause the video and try this on your own. Okay, let's look at it, see if our answers agree. Okay, so I need to find f of 12, and that doesn't look like fun. So f of 12 is 5 times 12 squared plus 7 times 12 plus 5. Okay, 12 squared is 144, and 5 times 100 is 500. 5 times 40 is 200. So that's 700, and 5 times 4 is 20. So it looks like that's 720 plus 84. That's 804 plus 5. That's 809. I'm just going to verify what I did here. Not that I'm doubting myself. Sometimes you just need to verify yourself. So that's 222 to 720. Yeah, that looks good. All right, so f of 12 is 809. And now I need to find f of 7. So f of 7, this is 5 times 7 squared plus 7 times 7 plus 5. So I think I already did 5 times 7 squared before. That's 49 times 5. That's 245. 245. Let's erase this business. So that's 245 plus 49 plus 5. So if I just add these two, that's 250. So 250 and 49 is 299. So that's 299. Okay, and this is f of 7. So f of 7 is 299. So my formula is that f of 12 minus f of 7 is 12 minus 7. F of 12 is 809. F of 7 is 299. 12 minus 7 is 5. Let's see, when I do this subtraction, I should get 510, correct? That looks about right. And if I divide that by 5, it looks like that's 102. All right, so that looks like to be 102. That's our final example. This is one of our easier topics. One thing I should point out, so the common mistakes on this topic, so just keep this in mind as you're doing it, is to not subtract, is to add and not subtract. So just like in the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So this is f of b minus f of a over b minus a. Make sure you subtract. That concludes this lesson. We'll see you next time.